Hey, AP Physics students, how about some hints about T14.2, page 628, number 28, or 20 and 29. Start with number 20. Now, as you look at number 20, it's got two stars, and it's because there are several little steps here, but it's not that terrible of a question. So let's look at a couple of features about this one. So number 20 talks about a beam of visible light, and it tells you the wavelength. It shines perpendicular to a particular surface, and it tells how many photons per second are hitting it. And of course, what it's asking here is obtain the average force that it exerts. And this is an interesting problem because it was believed early on in the study of physics that there should be no force applied by light on a surface of something having had no mass. But we know that light actually does have momentum. The momentum for a photon, from your notes you see the momentum of a photon is P equals H divided by lambda. So there's a useful way to start this out. Now, because this is about momentum, and because we're asking about force, recall that the impulse, which is force times delta t, is the same as the change in momentum. So this will be a hint to get you started here. It talks about how many photons per second. So you could always use a delta t of 1 second. That might help. And then one more little hint is there is a part A and a part B. Part A, regarding part A, the light is reflecting from a surface. And as it reflects from a surface, the delta P, the change in P, is going to be the final momentum minus the initial momentum. Okay, remember what delta is. So again, it is the final momentum, which is the opposite of the original momentum, okay, minus the original momentum. So notice it's twice the original momentum, with a negative sign telling the direction, but it's twice the original momentum. Hopefully that will help you to solve number 20. Now let's look at number 29. In this one, we're talking about a television tube, which basically shoots electrons, and it accelerates them from rest with a potential difference. And they would like to know the potential difference. The de Broglie wavelength is given to you. So again, when you see a problem like this, you say, all right, I'm going to look for the formula for de Broglie wavelength. And the de Broglie wavelength, which they give you, obeys the formula momentum equals h over lambda. So this should be helpful in finding the momentum. Well, of course, that doesn't give you the potential difference, which is voltage. But remember, there is this thing called conservation of energy. So since momentum is mass times velocity, no reason we can't find the velocity. And since kinetic energy that you pick up comes from potential energy, so the potential energy you find, which will help us find the voltage, the electrical potential energy, comes from then the kinetic energy. And so, but the potential energy is the same as for electrons or charges, Q times the voltage. All of these should help you solve the problem. Have a nice time.